Hi guys, we are going to look at assignment 3.3. Okay, so you're going to upload all of today's or yesterday's notes. We did example 2 and quite a bit of notes. And then these questions, 12 to 14, 19, 22, 19 through 22, and 28 and 29. So let's do it. So question number 12 went like this. Shannon says that that's our image, right? Shannon says that our image is a rotation of this pre-image about P. What is the correct transformation from the pre-image to the image? So if I rotated Z, it looks like this would be, I don't know, back 3, up 3 maybe, or back 2, up 2. Then rotating it would be back 2, down 2. So Z should be, Z prime, if we rotated it, would be there. Because remember, our rotation rule for 180 degrees would be the X and the Y are the same, they're just negative. So if this was 2, 2, now I'm at negative 2, negative 2. So now if I look at this as maybe the coordinate negative 1, 0, negative 1, 0 would be same spot, positive 1, 0, right? It just made these positives. So that's right. So maybe that's why Shannon got confused. That would be the same coordinate for a rotation of 180 degrees. Now let's look at Y. So if I look at Y, it looks like I'm back 2, down 1. So back 2, down 1. And so I follow my rule and it changes signs. So positive 2, positive 1. So a rotation about P would look like this. So that's Y. That would be coordinate Y. So notice this is what a rotation would look like, pre-image and image, and that's not what we have. So you're probably already figured out that this would be fold on top of. So this would be a reflection. Notice the distance. If this point is in the middle, this point is in the middle between line Z and Z prime. This point is also in the middle between X and X prime, and this point is in the middle between Y and Y prime. So this is the evidence that this reflected over this line. Okay, 13. It says the mathematical connections. Point A prime and B prime are images of point A and B after a 270 degree rotation about the origin. So let's go back in our notes and get the rule. So 270 degrees is this rule. So we want to copy this rule. Our original coordinate transforms so that they switch spots and the X is negative. So let's go back. I need to switch spots and the X is negative. So that's my rule for a 270 degree rotation about the origin. So now it says if the slope of AB is negative 3, what is the slope of A prime B prime? Okay, so let's just use our example in class. We used this triangle that is 2, 5. So that would be triangle 2, 5. This would be point A. And after my rotation of 270 degrees, that would be they switch spots and the X1 is negative. Okay, so that would be positive 5, 2, 5, negative 2. So this is a rotation of 270 degrees. So if I think about it, this is 90. This is 2 90s. This would be 3 90s, right? And that's what we want. 270 degree rotation. So our new location would be here. That would be A. Well, I don't know why I wrote A prime. This would be A, and this would be A prime. Okay, that follows the rule. So now let's look at the slope. So they're saying, would it be true if the slope of AB, so I'm just going to randomly call this AB, right? This is AB, this length there. And now let's look at A prime, B prime. So this would be A prime, B prime. So this is AB, right? And this is A prime, B prime. So they're saying if the slope of A prime, notice that, oh, those are at a 90-degree angle. Do you see that? Here's what else I noticed. These two hypotenuses are at a 90-degree angle. These two short lines are at a 90-degree angle. So I think I figured something out. If I had one of them that was a slope of -3, the slope of a 90-degree angle is, ooh, good review, opposite reciprocals. So I think that no matter the orientation, AB is perpendicular to A prime, B prime if, because I noticed it for all of them, if and only if I do a 270-degree rotation. And that's what I have. So I want a slope that's the opposite reciprocal. So if my slope is -3, then my perpendicular slope would be +1/3. Cool. Nice. Neat question. Okay, now it says the diagram shows a rotation of 90 degrees, but this is after they moved it. So I'm actually going to go backward. So what is 90 degrees backward? That's where we need our equivalent. So 90 degrees, it rotated 90 degrees back. So this point, we saw that today in our lesson, would be, I think, here, right? A would be here if it rotated 90 degrees. So what happens when I do 90 degree back? That's the same as 90 degrees clockwise. So I'm trying to figure out, well, what is the equivalent rotation of 90 degree clockwise? So let's look in our chart, because this one is my image, and I have to work backwards and figure out, well, where was my pre-image? This one's sneaky. Okay, so what's equivalent to 90 degree clockwise? So if I look at my notes, we said 90 degree clockwise is the same as 270 counterclockwise. So I can use this rule because 90 degree clockwise is this rule, just like 270 degrees counterclockwise is that rule. So it looks like the X and the Y change spots and the X is negative. So let's use that one. So our rule is the X and the Y change spots and the X is negative. Let me just double check. X and the Y, yeah. X and the Y change spots and the X is negative. Okay, so back to our number 14. If I had a coordinate, so it needs the coordinates of all of them, A, B, and C. So this time I'm going backwards. This is kind of neat. I haven't done this. So this is the coordinate -2, +1. B is -4, -2. C is -4, -6. D is -1, -3. And these are prime. They graphed the image. So working backwards, I can figure out, well, what was A, B, and C? And D. So following the rule, I need to put them backwards, switch the spots, and then change the sign of the X. So let's just do the switch the spot first. So switch places, switch places, switch places, switch places. Okay, now I'm going to put negative X. So negative is a positive. Negative is a positive, negative is a positive, negative is a positive. Okay, And so that's my answer. I'd take that, and you might have cleaned it up too. And instead of said the positive, just the coordinate 1, 2, -2, 4, -6, 4, and -3, 1. Nice work. Check out the next video for some